Welcome to our webinar, Gemini 1.5 Pro, native audio, file API, JSON mode, and 1 million context window. My name is Yukti Dwivedi. I work as a growth analyst at SingleStore, and I'm so happy to be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars and demonstrating data and AI use cases and new technologies and tools. I will start posting about our upcoming webinars every week. So if these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or ideas on topics that you'd love to if you would love to see them in future sessions. Okay, so speaking of future sessions, we've got great sessions coming up. Next week, Monday, which is the 29th, we'll present Is RAG Really Dead? Hands-on with Gemini's new token context window. And then on April 30th, which is a Tuesday, we are presenting Meet Llama 3 run locally with more power, less cost, and full privacy. And then on May the 2nd, we are presenting world's fastest LLM apps with Grok and SingleStore. If any of these topics sound interesting to you, please RSVP right now. I'll be putting everything in the chat for you to access. All right, back to today's topic. You're welcome to participate in the discussion throughout the session using the Zoom Q&A button at the bottom of your console. We have an internal mission statement to answer 100% of the audience questions, even if that means following up with folks afterwards via email. So please ask away, do not hesitate, but make sure you've logged into the Zoom with your name and email address. We will not be answering any anonymous questions. I hope that's understandable. Also, we'd love for you to have a dynamic experience during this webinar. So please feel free to leverage SingleStore DB as you watch. Anyone who tries it today will be entered for a chance to win either brand new branded AirPods or Meta's new Ray-Ban LLM smart glasses. It's your choice. You can opt in and choose. Simply click this link in the chat and log in. I'll be putting everything for your convenience. SingleStore has also had a free trial offer for many years, but just in the past few weeks, we have also announced a new free shared tier, which we'll talk about a bit later today. All right, moving forward, let me announce our speakers today. We have Alex, who's a growth engineer at SingleStore. His formal training was from Stanford Computer Science program, which is so cool. And he has expertise in big data, machine learning, and AI. He's quickly becoming a regular speaker in our weekly webinars on data and AI. I'm so happy to have him here. Welcome. We are so happy that you have joined. We have so much to learn from you, Alex. Okay, the floor is now yours. All right, thanks again and welcome everyone.
Thanks, Yukti. Like Yukti was just talking about, we do a lot of these data and AI webinars, and we'd be really excited for you guys to try them out. So do feel free, or we do encourage you all to check out the raffle. It's a great way to get involved with the project that we're talking about here today, the demo we're talking about here today, and then also, have a shot at winning some Ray-Bans or AirPods. Great. So as everyone is probably familiar with, we're all here today because of, all of this excitement around LLMs, around RAG. But I wanted to make sure that we all kind of have the same level foundation before we dive too deep into the rest of this. So I wanted to talk first about this emerging architecture that we're really seeing coming out now for LLM applications. And that's really going to be centered around this concept called RAG. And RAG is essentially augmenting our LLMs or providing our LLMs with information that's contextually relevant to them, so that they can use that information and provide us with more helpful, non-hallucinated and relevant answers. And so it sounds simple, but as with many things in life, it's easier said than done. This is a very high level overview of how it works. The end user prompt is passed to, the Gen AI application, which is probably what many of you are building here today. And then that prompt is passed somehow to an LLM, and then that prompt is somehow passed to the company's data store, which then gives you the contextual information that's relevant to the user's query, whether that be through a variety of methods, and then finally the LLMs are made aware of that information in the prompt, and the whole loop is so that we can get that more helpful and relevant answer in the end. Diving a bit deeper into this emerging AI stack architecture that we're seeing here, you know, at the very uppermost layer, we have all of the ways that end users actually use LLMs, right? And that's going to be your UI. You have, you know, conversational UI interfaces like ChatGPT. You have, you know, we're seeing a lot of browser plugins come out that interact with, you know, your web browser more directly. You know, there could be widgets, there could be smaller components embedded inside of websites. But anywho, those UI components have to talk to the LLMs and your contextual data layer somehow, and that's through the API layer, right? And that's probably where most of you are developing here, and really where we're going to be diving into most of our code. And that's going to be, you know, your API connectors. Those are going to be your LLMs, your hosted LLM endpoints that you're hitting. And then finally, at the very bottom layer, right, what we like to think of as really the foundation of your AI stack is not your LLM, but your contextual data store. And you know, we're a little biased. We think SingleStore is the best here, and we'll jump into a few reasons for why. But this is going to be where all of your AI relevant information is going to live. And not just that, you know, all of this data has to be able to be easily searched over, you know, both lexically, you know, using traditional SQL query languages or SQL compatible query languages, and semantic search, which we'll get into a little bit. You know, just doesn't just have to be searchable, but it also has to be, you know, quickly accessible, and it has to be simple, right? Who wants to deal with, you know, a bunch of different, you know, hosted databases, right? When all you really want is the most relevant and helpful information for your AI to act on, right? And you want that information quickly. Kind of diving a little deeper into what that contextual data layer, what actually lives inside of SingleStore. You know, as outputs, we have obviously, you know, data products, data stories. We have, you know, the information that the user is actually querying for. But inside, you know, there's a lot of different moving parts that actually make all of this possible. You have we've recently released, you know, some really new exciting compute features inside of SingleStore, that like SingleStore notebooks that allow you to run code right next to your data, and run it at the lowest possible latency to your data. You know, you also have above, you know, where all your data actually lives in tables and in unstructured NoSQL formats. Above all of that, you also have, you know, the semantic layer that actually allows you to access your data, right? That's going to be, you know, whether that's semantic search, whether that is, you know, different data access policies that you have layered on top of your data, you know, for certain sensitive forms of data, that's going to be all living inside of your contextual data layer. We've talked a bit about semantic search, actually, and I'm sure many of you are familiar with, you know, traditional lexical search techniques. You know, lexical search is basically when you go to Google and you type in a query. That's going to be a very, very, very fancy form of lexical search. I'm sure it also blends in some semantic search, but really at its core, that's going to be lexical search, and that is specifically matching against keywords or matching against the exact text of your query. Semantic search is a little different, and semantic search is what makes RAG and, you know, LLM augmented search so interesting. Semantic search says, hey, what if we didn't search by the exact wording of a search query, but instead we searched by the meaning or intent behind a search query, so we can pull out the information that is useful to the meaning or intent of the user's query, not just exactly what they're searching for. That's going to be done through this process called vectorization or embedding, right? Those two terms are kind of interchangeable in RAG. And embedding is essentially this process by which we convert a user search query into what's called a vector, which is you can think of as a long list of numbers. And that vector is then searched it's searched against a database containing other vectors that have been generated from your corpus of data, your corpus of company data or proprietary data that you'd like your LLM to have access to. And in so doing that process of search, you get the most relevant pieces of information to that user's query, not by exact keyword match, but by semantic meaning, by the intent behind the user's query. So let's illustrate this. Say you wanted to learn more about Python, right? Say, for example, your user's query had something to do with Python, and you also know that they are a developer, right? The corpus of data, maybe it includes all of Wikipedia. And a traditional lexical search method might return to you like, Python as in the animal or the snake that lives in the Amazon rainforest. But that's not that relevant to your user's query. If you used a semantic search method, right, you might instead get Python as in, Python Jupyter notebooks or Python, the programming language. And you can see how the semantic search is able to actually get at the intent behind a user's query. Some considerations for vectorization, anything that we're using for real-time contextualization with LLMs, that's going to be fair game to be vectorized. In fact, you're probably going to want to vectorize it because user queries in this RAG space are often, more geared and more compatible with this kind of semantic style of searching as opposed to lexical, although there are hybrid methods that have come out now that are really cool. You're going to want to be careful about vectorizing sensitive data that you then store along with non-sensitive data. You're going to want to think about, again, those data access policies and governance to make sure that, when you perform that search over your vectorized data, you're not returning any results that aren't relevant to the user. Great. So, here's the big reason that we're all here today. This is going to be, this new really exciting LLM that's come out from Google called Google Gemini Pro, specifically Gemini Pro 1.5. And not just, all of its amazing text-based capabilities, but also its really incredible multimodal capabilities. We've already done, some past webinars now on the multimodal image input capabilities of Google Gemini. Highly recommend checking out one of those if you're interested in image input and the multimodal capabilities in that sense. But multimodal, and for those that are unaware, multimodal just essentially means multiple different input types for an LLM. An LLM that doesn't just take text, it doesn't just take text, that also takes images, right, and many other forms of data. Multimodal does not just entail images, right? Today, we're really interested in exploring Gemini's audio capabilities, right? And you might be wondering, hey, what's so interesting about audio capabilities? What's so interesting about audio capabilities? I can download a transcript of a YouTube video pretty easily. I don't need an LLM to do that. And what we're talking about here is pretty materially different from just speech to text, right? We're talking about native level audio support to make audio input on parity with text input. And so what that means is, and we'll show you guys this, you can put in audio that maybe doesn't even necessarily have any human speech in it. What we're going to use as an example here is actually like a Mozart like concert, right? You can put in something that has no human speech in it, And the LLM is able to understand at a really fine-grained level what's going on in that audio, and in a really general sense too. So like if you put in, Mozart concert, for example, you can ask it to give you, the a list of the instruments that are playing, right? Maybe you're actually giving it, a meeting transcript, or you're giving it just raw meeting audio. And in that case, you do have some human speech, but maybe you'd like it to do something more interesting, right? You'd like to grab out some action items, or you'd like it to be able to, pull out by the timestamp, the most kind of actionable, like kind of moments from the meeting, right? This is what native audio support allows, that um, kind of previous speech to text followed by typing that text into a text only LLM did not allow. And I'm happy to talk more about some of the capabilities here, but I'm sure for all of you that are joining us, you're probably well aware already of the use cases that you're interested in pursuing. One other really exciting capability here is that Gemini is capable of 11-hour-long recordings as inputs, right? So you're not even thinking about, just putting in, one concert or, one meeting. Maybe you could even have it like listening on, a looping basis, like your entire day or your entire life, right? And, it's you're maybe moving between, talking to different people, and then, maybe there's some environmental sound, and it's able to actually understand everything that's going on, not just the speech. So happy to answer more questions about, what makes this native audio support so exciting for us. But why don't we just jump into it and kind of get into the code here. I'm going to, oh, actually, before we do that, we're going to talk a bit about SingleStore. Sorry. So what is SingleStore? We are, running this webinar, and we'd also love for you to try out our database. We think it's the best database in the world to transact, analyze, and contextualize data in real time. We run on-prem, in cloud, and in hybrid environments. And so, we started off really strong in memory relational databases. Originally we started off as MemSQL, but we've since moved into a bunch of really cool data modalities and data storage formats. Obviously today we're talking about vectors and semantic search, and we've actually supported vectors and semantic search since 2017. So we are one of the kind of best equipped companies and databases to actually handle vector and semantic capabilities. Just some stats and metrics on some of our customers. And what makes SingleStore really special is that, under the hood, obviously we have super fast access speeds, right? Industry leading access speeds, and complex query capabilities that run in, at the millisecond level. And the way this all works is, at the uppermost layer, we have the data sitting in memory in super fast, RAM, right? And then we have a proprietary technology that essentially makes it so that as you add more data, the data that's most accessed stays at the top in super fast query capability, and then we move to local SSD storage, and finally to bottomless kind of like S3 bucket storage in the cloud. And that's what really makes SingleStore so different from some of the other databases that you'll find out there. We really provide one single place for you to store not just your relational data, but all of your unstructured data, your vector data, all in one database, all queried by SQL or queried by semantic search APIs, so that you're not running around setting up different data access policies for one specialized vector database here and then a relational database over here. All right. We'll just run past a few of these. Like I mentioned earlier, SingleStore notebooks is a really exciting capability that we've rolled out in the last few months and that we'd love for you to get to try. And so actually today our demo is going to be in SingleStore notebooks. This is a web-based notebook, very familiar. For those of you familiar with Jupyter notebooks, it's going to be very familiar. And it's basically the best way to run code right next to your data. And you'll see how that works in just a minute. It is, I think, one of our best features. It's super cool. Great. All right. Just a little bit of background. Today, we're actually going to be working with LangChain. We're going to be working with the SingleStore integration inside of LangChain to interact with our vector data. And then we're also going to be using, and you'll see this later, we're going to be using the Google Generative AI SDK as well. Great. Let's go ahead and jump into the code here. And I know we're getting a few questions, so do keep those questions coming in. I will pause after showing this demo to see if we can get to a few of these questions, and we'll have time at the end as well for questions. All right. Let's see here. Great. Okay. So actually, before we go into here, I should show everyone how to actually sign up for SingleStore. So if you go to our raffle link, or just go to this link here, singlestore.com/cloud trial, you'll be able to sign up for a free SingleStore account. And you can just put in your first name here, last name, company email address, etc. And once you've signed up for the free trial, you can actually access our free shared tier, which is actually not a trial and is actually free for everyone to use for hobby level projects. It's a really great way to get up and running with SingleStore, and to kind of try out some of the features that we're showcasing here today. But anyway, once you've gotten into your portal, you're going to want to create your first group. And that's going to be, depending on your needs, that's going to be either the starter workspace or the standard workspace. And you can see here, we are multi-cloud. You can host on AWS, GCP, Azure. But a few clicks here and you'll be up and running. And I'll show everyone here now how to actually access the code that we're going to be working with today. So once you've got your first workspace spun up with a database spun up, and you've got it running, you're going to want to go to this Notebooks tab under Develop here on your left sidebar, and then I believe everyone has access. Do we share out in the chat the demo link? Here, I will share it out actually. There we go. So if you go to the demo link, you'll be able to download the Python notebook that we're going to be using here today for our code demo. And then once you've got that, you're going to want to go into your Notebooks tab, import from file. And then you're going to want to upload your file here. But I actually already have it uploaded, so I don't need to import it here. We can go actually straight into it. All right. Great. So just a quick overview of what we're going to be doing with our demo today. We're going to be using the Google Generative AI SDK as well as the LangChain library and the SingleStore integration inside of LangChain to upload programmatically an MP3 file. So in this case, it's going to be like a Mozart concert. Upload an MP3 file, have the have Gemini actually describe it for us. Then what we're going to do is we're going to embed that description of the MP3 file and upload it to our SingleStore database. And we'll show just exactly how easy it is to get up and running with a SingleStore database inside of SingleStore notebooks here. So just really quickly, these are a few of the required packages that we'll be using today. The Google Generative AI SDK, a few of the LangChain packages. We actually don't need this LangChain OpenAI package. We're only using Google Generative AI packages today. And SingleStore, we're just going to be importing the Gen AI package from Google. And then, you're going to want to get your Google API key from aistudio.google.com. And so everyone can go there and set up their Gemini API access and get their API key, but that's pretty simple. That's just a few clicks from AI Studio. Once you have the API key set up and you've configured it, it's actually super simple to take any audio file that you are interested in prompting with your LLM and then actually prompting it, right? All you do is, here I'm downloading the file locally before uploading it. But if you've already got it on your local machine, all you need to do is use this genai.uploadFile method to upload the file. And you provide the exact path to the file as an argument. And then you return this your file object, which you can then very, very simply pass in to the model's context window, just like this. First, you're going to define your prompt. Here, we're just asking it to listen carefully to an audio file and provide a one-sentence summary. We're using the latest Gemini 1.5 Pro model because that's the model with the audio input support that we're interested in. And then what we're doing here is we are passing in a list the prompt and then the file object that's returned by this upload file method. And just like that, we're able to get the response text. And we can see the audio file contains a series of classical music pieces featuring piano strings and woodwinds. If we asked for, please provide, a list of instruments that are played, actually, I usually don't do live demos, but we're actually going to go a little off rails here. I want to show everyone here how cool this functionality is. Let's see here. And Akmal, are we answering all of the we're answering some questions in Q&A? Any questions in Q&A that are really burning so far?
There's a couple there, Alex. So there's a couple, and I'm not sure if you have the knowledge that I mean, because I don't know how extensively you've used it. But Carrie's got a question there. Says, can you comment on the quality of OCR capabilities for Gemini versus OpenAI versus Textract? Thanks. I mean, I've used and I've used the PDF tooling from LangChain in terms of extraction of documents, but I haven't used OCR per se. I don't know if you've had a chance to test that out yourself. It'd be interesting to see how good the quality is.
Yeah, that's a really good question. So OCR, for everyone unfamiliar, is optical character recognition, and essentially what we're being asked here is, how do the OCR capabilities of the best models available from OpenAI compare to the best models available from Gemini? And the unsatisfying answer is that they're basically about on par, though for certain use cases, one may actually be significantly better than the other. And the way that you find that out is by benchmarking. So you're going to want to set up a standardized benchmark based on your company's data that you would like to test these models on, and then you're going to actually run these models and then see which one works better for your use case. In some cases, it may be that the OpenAI GPT-4 vision model is better. In some cases, it may be that the Google Gemini model is better. And then yet again, in other cases, you might find that a traditional OCR method or an open source vision model off the shelf is actually sufficient. So we have webinars on all of these capabilities, and I would highly recommend checking them out. But that's the kind of like long and short answer is it depends, and you're going to want to benchmark. Actually, I totally blanked and did not resume our workspace before we started this demo here today. So you're all just going to have to trust me and take my word for it that the Gemini 8 audio capabilities are really cool. And also, if you just run this, you'll see that you can fiddle with the prompt as much as you'd like and get some really cool results out of it. But once you have this response text, you can really go wild with the response text. I'm sure all of you can imagine, the kind of business capabilities and business logic that's enabled by native level audio understanding from LLMs. But what we're interested in at SingleStore, and probably what a lot of you are interested in, is being able to semantically search over these embeddings, right? Or semantically search over these audio descriptions or these text descriptions of audio. And so SingleStore Notebooks makes that super simple when you combine it with the SingleStore integration and LangChain. Really, all you have to do is import SingleStore from LangChain, use your embedding model of choice. And now we actually did a very recent webinar on fine-tuning your embedding model. And if you're more interested in the actual choice of embedding model, that's a great webinar to check out. But today we're going to be using the Google generative AI embeddings, the Google AI Studio embeddings. Those are great if you just kind of want to keep everything under the Google umbrella. And then the really cool part about using SingleStore Notebooks and accessing the database from inside of SingleStore Notebooks is that connecting to your SingleStore database is one line of code, and it's just this line of code. We kind of provide all of the environment variables so that this kind of connection string is pre-filled for you in the background, and you don't have to think about it at all. Then we initialize our SingleStore database. We're just defining a table name here and our embedding model, and and then hopefully everyone can see here. We're just defining, a very toy example, but hopefully everyone can kind of extend it to their own use case of adding our audio description here, some filler text as well. We can include some metadata like the path to our audio file, so we can access it once we've retrieved the response text. And then we see, just kind of a glimpse of the semantic search capabilities here. In our text description, we're only describing just some classical music, some instruments, nothing really about Beethoven or Mozart. But if we're just searching the word Beethoven, we'll get as the most similar piece of text, we'll get this audio file description, which talks about classical music. So that's a pretty cool demo, I think, of how semantic search actually works. Not by exactly matching lexically, but by getting at the intent behind a user's query. So great. I'm sure we have a lot of questions, and we actually have a lot more time than I expected for questions. So we can just get into some of these. Akmal, any interesting ones that stood out to you?
There's a couple of open ones at the moment there, Alex. So Carrie is asking, can Gemini audio support reliably isolate audio by speaker? So I'm guessing left and right speaker. Is it able to differentiate between that? That would be interesting if it could.
That's a really good question. I imagine that it's able to differentiate by speaker. Like the answer to the question, can it, is it probably definitely, I mean, I'm sure it can.
Yeah.
But again, you're going to have to benchmark on, speaker differentiation tasks. Because, what we've been finding with all of these really cool LLM technologies that, have been releasing at, an almost like unbelievable speed, is that the initial capabilities are often more than we expect, but where you really get to enterprise grade products, production grade products, is all of the different edge cases that the LLM might run into, because users in the wild do weird things with your product, and really stress testing those edge cases and making sure that they work, and that they're rock solid, right? So the answer is basically speaker differentiation tasks probably work, but you're going to want to benchmark on your own tasks and your own data.
I think one of the things that a while back I did a webinar, and it was analysis, essentially trying to build something that was me, capture my voice, have something that understands the way that I speak sentences and this kind of thing. And I was surprised to see that there's some really great software out there. Some of it is free, or you get a lot of kind of credits, and it can differentiate between different people. The strength of one speaker versus another, it can identify that, and if you've got multiple people. So I'm guessing that something like Gemini would not be able to have a problem with the left speaker and right speaker. We can check that, and we have committed to answering all of these questions. Even if we can't do it straight away, we will research that and get back.
So got a really interesting question, and from a user named Carrie, or a webinar visitor named Carrie. And the question is, for the query, is it fruitful to ask questions similar to word to vec? For example, king plus queen minus prince. And so for those of you unfamiliar, word to vec is essentially one of the very earliest methods for embedding text into vectors. And this is a really cool kind of archetypal example where if you add the vectors for king and queen and you subtract prince, you get a vector that's very close to the vector that you get if you embed the word princess. So you can sort of do some like word algebra with the word to vec method. And I believe you can. It depends on your embedding model. You cannot actually, I don't believe you can actually, like, in your text input, do that sort of like word algebra. What you actually end up performing those operations on is the vector embeddings of each of those words. But yes, in principle, you are able to do that. But yeah, very, very cool kind of like academically inclined question. That's almost like a test question I had in like an NLP class I took a few quarters ago. All right, let's see here. So we get another question from Zichi, who asks, if I had two media files where the content is very similar with minor differences, what's a good prompt approach for Gemini to describe the media, but to keep the minor differences before uploading the responses or description to the database? So I'll give the first pass approach that I'd take, and then I'll like kind of caveat by saying you're going to want to benchmark. The first pass approach that I take is basically just prompt the LLM with what you'd like. So just be like, here are two audio files that have some very minor differences. Give some few shot examples of like what those minor differences might look like. So, I don't know, maybe like it's some recordings of webinars, right? And there's some minor differences in like how the intro is done, and you're kind of putting them back to back, you can be like, well, these are 2 recordings of webinars, and there's an intro that lasts a few minutes at the start, and I'd like you to tell me how they're different. You can just try that, provide some few shot examples. And oftentimes that's going to be actually a very performant approach. That's the lowest hanging fruit, but you're going to want to also benchmark if you're going to be using this in any sort of production or enterprise capacity. So that's going to mean coming up with a bunch of different prompts, testing them across, testing them across, a diverse data set. And maybe you're even trying not just, the Gemini model, but you're trying other models as well, open source models, to really try to get the best kind of cost per token that you can. Okay. Let's see. So we got another question from Durga, who asks, can Gemini do speech-to-speech translation with voice preserving? That's a really good question. My understanding of how Gemini works today is that the output is limited to just text, though I believe they're very quickly adding image capabilities. The kind of capabilities talked about here in this question, which is, can you input audio into Gemini and then get audio back, which is the same speaker talking, but in a different language. That's kind of hinting at the sort of next generation, any modality to any modality, any input modality to any output modality models. Those are not yet out, though I'm sure Gemini will have those capabilities in the future. But we may jump the gun a little bit on this. There are some commercially available APIs that do speech to speech with voice cloning or voice preserving. I think 11 Labs is one of the APIs that does that, or one of the companies that offers an API that does that. But as for any modality to any modality LLM, those are still just a little further down the line. Great. Let's see. Carlos asks, how can LLM architectures be scaled to handle the massive computational demands of large-scale language models while maintaining efficiency and performance? That's a really good question. If I knew the answer to that question, I'd have my own lab at Stanford, but I don't. Yeah, that's let's see. I think this question is probably much better answered, in an LLM engineering webinar or something similar. But my understanding at a high level is LLMs are basically being made more sparse, so their weights are, there's less weight activations when performing inference, and there's also a bunch of kind of efficiency tricks that you use when performing inference, because that's the biggest kind of ongoing computational demand when you're serving an LLM. Like you're batching and scheduling user queries to the LLM all at once, and so on and so forth. But great question. I like the energy, but I am woefully underqualified to answer that question very meaningfully. Kieran asks, and I see Akmal's already typing out an answer, but Akmal, I'm going to jump the gun on this, and I think this is going to be very useful for everyone else to learn. Is it necessary to use only the same embeddings to store vectors to store in the database, and search embeddings which check those vectors that are stored in your database? The answer to that question is yes, actually. And the reasoning behind that is essentially there's really two steps to any RAG process. There's going to be the actual, there's the search step, which everyone is hopefully familiar with at this point. We just demoed it in code. That's going to be searching over, your database of vectors, right? But the step that's oftentimes abstracted away, and you can even see in our code here is abstracted away, is the actual embedding step, right? So you saw in the code how we defined our embedding model as the Google Generative AI embedding model, but you didn't actually see the text be embedded, right? And that's because the way that the LangChain integration is set up, you define the embedding model when you initialize, the vector database. And once you've defined it, every subsequent document that you add or every subsequent piece of text that you add is embedded with that embedding model, right? And that's important because when you perform search over your vector database, you want to make sure that your that the embeddings that you create from your search query are the same sort of input dimension as your stored vector embeddings. Because the way that you actually do search, and this is maybe getting in a little bit into the weeds, but it seems we have a bit more of an academic audience here today, is you do cosine similarity search against the vector embeddings. And so that's essentially checking in very high dimensional space which embeddings are closest to your query embedding. And that doesn't work if you use a different embedding model that has, say, for example, a different, output dimension, or even if the output dimensions are the same, embedding models themselves are pre-trained on big, vast corpuses of training data, and they learn very specific ways of grouping, different concepts in high dimensional space. And if you use one embedding model for, embedding your corpus of data, and then another embedding model for embedding your query at inference time, you're not going to get the best performance possible. So that's the kind of long way to answer that question. Okay. Akmal, any other questions that are interesting, standing out to you?
I think let's see. Carlos has asked a couple of questions. So there's one that's outstanding. He's saying, what techniques can be used to enable continuous learning in LLM models, allowing them to improve their performance over time? So that's a good question. So I think commercially, for the likes of OpenAI, for example, or Cohere or others, we kind of have to rely upon the vendors to do that. And even with open source models and open source software that's available, again, you're very much reliant upon the community or the vendor to provide that for you. If you're going to do your own, you have much more control over that. And if you're going to build something specific for your environment, I'm guessing that you can do that in terms of adding new knowledge on a regular basis. The example that I use is Gemini from Google, which I don't use very much. I mean, I tend to use ChatGPT much more, but every time I go to the Gemini page, it just says, oh, it's just been updated. And you can kind of click on it and see when was the last update. Well, it's kind of like an hour ago or something. So they definitely do keep adding to its kind of knowledge base over time and its ability to answer more questions. Current affairs.
Yeah, just to add on a little bit, there's a few different ways that you can do it. Akmal mentioned one, which is if you host your own model, and that's really kind of the best way that you're going to get, this sense of continuous learning. Although, it is the most compute intensive, and that's going to be by continually fine-tuning your model on data that you collect, input-output pairs that you think are kind of golden examples of how the model should learn. And then once you've collected, 100 or maybe 1,000 input-output pairs, fine-tuning your own model on those pairs, and then benchmarking the new fine-tuned model on, the tasks and capabilities that you care about. And then from there, you kind of get this kind of virtuous cycle of a continuously improving model. But even when you're working with a hosted API model provider, you can still get this sense of continuous improvement. And that's actually, this is a kind of new technique that's coming out now called, MEMGPT, or some of you in the audience may be familiar with the paper MEMGPT. That's essentially giving the LLM its own vector database in which it can store little memory traces or things that it wants to remember about the particular user for future interactions, right? Like remembering that the user likes, more brief responses, or maybe more detailed responses, or maybe the user is, in the marketing team and is interested in understanding things from a marketing angle, and so on and so forth. Like you may have experienced this already with, custom instructions for ChatGPT, but the idea is a sort of self-maintained custom instruction set. And that's another sense in which, a model can continuously improve its performance over time. But good question.
Yeah, a couple of questions people are asking about. Sorry to interrupt you, Alex. Just a quick one. So I realize we're kind of moving on in time, but Sarada's got a question. Any suggestion for good resources to start learning Gen AI LLM? I've recommended this several times. Obviously, SingleStore is great. Okay, come to us. But if you want something independent, go to deeplearning.ai. Professor Andrew Ng from Stanford. He's the guy who founded Coursera. He's got a couple of startups going. The deeplearning.ai website is awesome. Regularly, almost on a weekly basis, free short course, typically 1 to 2 hours in duration. You learn something new. It's great. It's a mixture of open source and commercial technology. Just follow that and you'll get lots of knowledge. I've done all 30 plus courses that are on there now, and it's been well worth it because you just pick up some awesome knowledge from, very talented people from a variety of different companies. Even some of them are competitors of ours. I learned stuff, which is great. And Alex may have some recommendations too. So,
yeah, actually, I think deep learning is great. Deep learning is a great resource. Fun fact: it is actually, the Coursera, I believe CS229 course is what Stanford students actually take when they take the class on campus. It's a flipped classroom format where most of the learning comes from the videos, and then you have sections that you attend. So that's a really great resource if you're more interested in more ML engineering things. But yes, deep learning is also a great resource for some of the Gen AI stuff that we're seeing come out today. A few more questions here. Mohammed asks, if we use image embeddings and text embeddings, what would be a good practice to combine them? That's a really good question. If you already have, a bunch of image and text embeddings generated, I would recommend putting them into separate tables in OpenAI, or not in OpenAI, in SingleStore. And that's because when you query over your image and text embeddings, I assume you've used different models for your text and image embeddings. And so you're going to want to do a search over different tables when you actually, depending on the input modality that you get. I would actually recommend, though, as a best practice, or this is maybe not best practice, but something that I've found a lot of success with, is using a combined multimodal embedding model. So one really good example is OpenClip. And that's an open source embedding model that's been released by OpenAI as a research project, but has since been, there's fine-tuned versions of it all over Hugging Face. It's an embedding model which can take both text and images as inputs, and you can just spit you can spit the embeddings that it outputs all into one table, and then when you search over it, you'll get the text and images that are most relevant to your query, regardless of whether the query is text input or image input. So that's the way that I would do that. Also, we have a bunch of multimodal webinars that I would recommend checking out. We actually get into some of the weeds of that. Carrie asks, have you all had any luck with LLM fine-tuning versus RAG, in my experience, RAG is cheaper to manipulate and is more performant. Thanks. So the analogy I always like to give for fine tuning versus RAG is fine tuning is sort of like performing brain surgery on on the LLM and actually modifying the weights of its brain. And you do that if you would like to change how it behaves, like how it thinks even, and how it behaves. Making it more, much more likely to be concise, or making it, much more likely to output in JSON or something like that. So fine tuning is like brain surgery, and RAG is sort of like giving the LLM notes for the test when it takes the test, right? So it's able to refer to the information at hand, but it hasn't had its brain modified or anything like that. It just has access to new information, right? So that's the sort of analogy that I give. And yes, it is often cheaper to hand someone notes before they take a test instead of perform brain surgery on them. But again, you will want to benchmark on the tasks that are important to you, and fine tuning, for example, a smaller model or an open source model may actually be cheaper in the long run than doing RAG every single time. Obviously we are a very RAG focused database, but we want to give you the tips that are going to be most helpful to you. And for simpler tasks, where it's easy to collect data on what's a correct output, and what's kind of an ideal input, fine tuning on a bunch of those input output pairs, and fine tuning a smaller model that's cheaper to run, that you can run locally, for example, might be cheaper than, or is probably cheaper in the long run than stuffing in a bunch of extra tokens into your context window for Gemini or OpenAI, because those input tokens actually cost you more in the long run. The more input tokens that you put in, the more you have to pay. The more you have to pay for the API usage. So I think we're running up on time here. Any other burning questions, Akmal, or?
Yeah. Anything we miss, we will follow up on. So if you have asked a question and not received a response, don't worry. Okay, our mission is to answer 100% of all questions, so we can take those offline. But as you mentioned, Alex, we are almost at the top of the hour, so I think you'll want to do your closing speech and announce the winner as well. So over to you.
Okay,
Yeah.
Okay. I want to thank Alex for the presentation. It was so informative, and I actually learned so much. And a big shout out to Akmal for lending his expertise in answering everyone's questions. Without you, I don't know what we'll do. Also, most importantly, a big thank you to all the attendees for joining the webinar today. Quick notes before we announce today's raffle winner. We've got great sessions coming up next week. I put everything in the chat before I put it again. On Monday, we have Is RAG Really Dead? Hands-on with Gemini's new token context window. And on Tuesday, we have Meet Llama 3, run locally with more power, less cost, full privacy. And on 2nd of May, we have world's fastest LLM with Grok and SingleStore. Any of these topics, if they sound interesting to you, please RSVP right now. I'm hoping to see you all there. And for the announcement that you've all been waiting for, today's raffle winner goes to Mammon Thomas, who's a manager of sales engineering and cloud software at Lenovo. Congratulations, Mammon. And a big thank you again to all the attendees for joining the webinar today. Thank you for your participation. We really value your time and energy. See you next time and enjoy the rest of your day. You can find all the links in the chat. I'll be putting everything again. And thank you so much.
Thanks, everyone.
I think wrap this up, right?
All right.
All right. I've put everything in the chat. Please register. Thank you so much. And take care. Thank you, Alex. Bye, Akmal.
Bye.
Bye.